Hello, discrete math fans. Now we're going to talk about relations and functions. So when we talk about people, there's lots of different relationships. Mother and daughter, father, son. People can be married. Groups of people can have a relationship. They can, for instance, share a common ancestor, or maybe things that are not family related, like sharing the same employer, or just having a common country of origin. So those are relationships among people. Mathematical objects have relationships also. We've talked about sets and how sets can be said to be subsets of each other. That's a relationship. Maybe we'll say things like A is a subset of B, or B is not a subset of A. Those are mathematical relationships. You've seen other kinds of relationships, say between numbers. Expressed algebraically, we could say things like x is bigger than y, or y is equal to 2/3 x squared. Those are relationships between mathematical objects. Later on in this class, we're going to do a lot of work with divisibility. So we could talk about an integer m being divisible by another integer n. And it only makes sense to talk about this in the context of integers. In math, when we talk about relationships between mathematical objects, they're called relations. Let's go ahead and create a relation. All right, here are a couple of sets. A is the set containing the numbers 1, 2, 3. B is the set containing the numbers 2, 3, and 4. And we're going to say that an element x in the set A is related to an element y in the set B if and only if y is divisible by x. All right, we can talk about divisibility. These are all integers. So we're just creating this relationship. It doesn't have any meaning necessarily outside of just this little toy problem. We're going to use a shorthand. We're going to use the shorthand x, r, y for the sentence x is related to y. So when you see this capital R, we're going to use that for is related to. Now it doesn't actually have to be an R. Later on we'll use other letters. That's okay. All right, so for this relation, we can say that 1 is related to 2 because 2 is divisible by 1. That's how we're defining the relation. 1 is related to 3 since 3 is divisible by 1. 1 is related to 4 since 4 is divisible by 1. Right? So remember that x is related to y. X is related to y if and only if y is divisible by x. We can also say that 2 is related to 2, 2 is related to 4, and 3 is related to 3. And these are all just following the definition of the relation that we've created. Okay, now when we want to say that something is not related, we're going to say x is not related to y by putting a slash through the r. Kind of like when you do not equal. Then we can say that 2 is not related to 3, since 3 is not divisible by 2. 3 is not related to 2, since 2 is not divisible by 3. And 3 is not related to 4, since 4 is not divisible by 3. Now I don't want you to use the word related to transfer over to any of your understanding about how related works in the real world. When you say two people are related, well, if person X is related to person Y, then necessarily person Y is related to person X. In math, we're creating a generic thing here that may or may not happen. Okay, earlier we talked about the Cartesian product of two sets. So the Cartesian product, A cross B, it consists of all ordered pairs whose first element is in A and whose second element is in B. In this case, starting with the sets that we originally had, remember that A had the numbers 1, 2, 3, B had the numbers 2, 3, 4. So the way we can think about it is, based on the relation that we created, the elements of some of the ordered pairs in A cross B are related, whereas the elements in others are not. what we'll do is we'll create the set of all ordered pairs in A cross B whose elements are related. Remember, there were 6 pairs that were related, so this set right here tells us which ones are related. So for instance, we're including 1, 2 because 1 is related to 2. Why was 1 related to 2? Because 2 is divisible by 1. So knowing which ordered pairs are in this set, this one that we've created, knowing what's in this set is equivalent to knowing which elements are related to which. It's just expressing the same thing, maybe in a more compact way. So we can think of relations as actually being the set of ordered pairs whose elements are related by whatever condition we're interested in. All right, let's make a formal definition of what we mean by a relation in mathematics. So if we start with sets A and B, a relation R from A to B is just a subset of A cross B. And that's it. Given an ordered pair that's in the Cartesian product of A and B, we're going to say that X is related to Y by R, and we'll write X, R, Y if and only if X, comma, Y is in R. And then some of the language that we'll use, A is called the domain of R, and B is called the codomain. So the notation for a relation can be written symbolically. We can say that X, R, Y means that the ordered pair X, comma, Y is an element of R. And of course, if you write X is not related to Y, that means that X, comma, Y is not an element of R. Okay, that's all for now.